Hey, let's see if the sound is working, unlike the last time. I have put in, well, been researching a bit of external mics, guys, so maybe by the time next year comes around, I'll have it. Cool. So what we're gonna do is, I think last week when we left off, we were doing this paper and we did question one and part of question three. So we're gonna finish off this paper today. I'm sorry, I know like normally I'd have questions ready to go, but um, me going back to school tomorrow, and then starting school again on Wednesday. It means that it just means that I've got some other priorities on top at the moment. But yeah, I'll still carry on with the tutorials. I did make a promise with you guys that I'll kind of go through till the end of well, at least till the start of your guys' exams. So we'll just power through it. It's just only 2 weeks, so I'm gonna need a lot of fluids to keep going, but we should be all right. Um, Yeah, what do we got? We got today. Where's our usual suspects from today? Hey, Corin, welcome. Kulaz, what do we got? Let me just kind of show that to you. Where are we at? What am I doing next one? Geometry. It looks like just go into my website, mate. Like I'll put a link on the description below. You'll find all the links for the tutorials. Once that, I haven't actually set up the link yet, but once I set up the link, it'll pop up there. Just keep an eye on that website, or also if you click on this little corner here, it'll actually take you to the live document. And so when I'm actually working on the document, those links will probably get updated on either Thursday or Friday. So all of these will get updated Thursday or Friday. Nice, welcome from Hastings. All right, guys. So as I said to you guys last week, I was supposed to kind of finish this off later in the night, but my voice was absolutely shattered on last week whenever I did this. Which one was it? Was it Monday that we did this? 8th of November. Yeah, it would have been last week, Monday. So I guess we still have got one whole question two to kind of work through. So these are the questions we'll work through. Just give you guys a bit of a brief quick little summary of what we're going to be working through. So just your normal factorize and solve, then writing it as a single fraction. We've got solve the equation. This is a good one. Even though you feel like you might actually see like it might seem pretty simple, but there's a couple of tricks that you need to know with that one. And then we look at like a rearranging question. I might actually give you guys a couple of more practice based on that. And then we've got kind of like a model of a parabola, and then we've got to get the equation and try and kind of, yeah, you've got the context questions in parabolas, and we're going to try and solve it. And then finally with question three, we haven't actually done any, just to wrap up, we got a couple of log questions, and that's probably the last question that we'll do because the rest of the questions we have done before. So that's all we're going to work on today, guys. And so, yeah, we'll kind of get started on the straightforward ones. What should I say? Thank you, Elite, for that. For just kind of letting him know, actually. Um, oh, glad you're enjoying it, Tom. Like it's always nice when I guess that's one of the perks of actually teaching online because when you guys actually show up, you actually want to learn something. I'm not saying the kids don't learn in my class, but it's different, right? Like I remember 2 years ago when I was at my school, um, like in my old school, sorry, in my old school, and kids would be sitting in front of me, but then they would still prefer watching the video of me rather than me standing in front of them. So yeah, anyway. Look, guys, I'm going to give you guys maybe a couple of minutes to kind of work through this question. Yes, you're thinking, what's so wrong about this question? I can just do this in the graphics calculator. If you can do it in the graphics calculator, great, go for it. Chuck up the answers on the side on the chat there, and I'm going to tell you guys what you are going to get for your grades as I work through it. So I'm only going to give you guys, maybe like another couple of, maybe a minute and a half for it. 676 Tom, yeah. Well, I thought I read that as achieved, man, but I reckon you can, like, you get a couple of these tricky questions under your belt. 6 Tom, I reckon you can actually get a high merit. Like when I say a high merit, I'm talking like 18, 17 points fairly comfortably. Because really, if you think about it, if you actually answer all the merit questions correct, you're going to get 18 points. And then you just got to make sure you get maybe one or two excellence questions correct, and that's it. You get close to that 21 points, magic 21 number, which means you'll get a excellence. Anywho, enough talk. Keep going through this. Chuck up your answers. Oh, glad you can join, Bright. It's always nice to have people coming in from like different year levels. Cool, guys. As you guys can see, the answers are coming up. The solutions, yeah, it's pretty straightforward, 5/3 and -3/4. So here's the thing, right? Like, and I know this is something that's actually quite useful to kind of know. I was about to write on my normal pen. So here we go. So people actually wrote down A is equal to, what do we got? 5/3 or -3/4. Yeah, that's all good, but there is a problem though in this question. It's actually saying factorize and solve. All right. When you guys give just these two answers here, what you've done is just solved this equation. You've not actually factorized it at all. You've just solved it straight away by putting it in the graphics calculator. While there's nothing wrong with it, in this particular exam paper, by the way, this was 2014, remember, this used to be a merit question. Why was this a merit question? Well, because you had to actually show some sort of factorization. Now, you could have done it two ways. You can't actually use quadratic formula in this. The reason you can't use quadratic formula is because it's not going to allow you to factorize. Quadratic formula is just going to solve it. All right, so that's kind of like the problem that you're facing right now. Now, here's the hint, the huge hint I'm going to give you guys on how to actually factorize this with the solutions that you actually have. All right, so if you guys think about it, your solutions that you have are 5/3 and -3/4. And I call this it's a bit of a cheat trick that you can kind of do, but it's always good to check it as well. And I'll show you guys a good example what I mean by to check it. So to go backwards to factorize, right? And this is the cheap trick that I kind of say to people. So you could write A is equal to 5/3 like this, and then A is equal to -3/4. And notice I'm actually writing it right at the bottom of the page and not at the top. Because as I said to you, this is kind of like the cheap little trick that you can do to kind of show the marker that you actually know what you're talking about. But what you're going to do is you're going to reverse engineer this. Like basically, this is what you're going to do. You're going to cross multiply that 3 with A. So you're going to go 3A is equal to 5. So we're going to write that as 3A is equal to 5. And then you're going to bring the 5 across to the 3A. So you're going to end up with 3A minus 5 is equal to 0. Now, why did I do that? Well, let's think about it, all right? We've got a quadratic right here. When we factorize this quadratic, we are going to end up with two brackets. And our two brackets, and literally this is what I'm going to do. I'm reverse engineering this. So your first thing is like your first bracket is equal to 0, or your second bracket is equal to 0. Now, notice what I've done here. I've actually figured out what my first bracket is, which is actually 3A minus 5. So I'm just going to kind of copy that back in there and this one in here as well. Now, the other way is looking at that A in the right-hand side, bringing the 4 across. I'm actually going to end up with 4A equals to -3. And then I'm going to get 4A plus 3 equals to 0. And guess what? I've got my second bracket there. So that's going to be 4a plus 3. All right, now this is pretty much going in reverse to kind of like work out what it is. And again, a really good thing to do is once you get those factors is to guess, not guess, to check it. So if I actually do 3a multiplied by 4a, well, guess what? That equals to 12a squared. And then I'm going to check my final terms, which is negative 5 times positive 3 equals to negative 15. And guess what? I've actually factorized this equation and I've actually solved it as well. So when you think about factorizing, it's like, as long as you get those two factors in there and then you kind of showing the working there, you're going to end up with a merit because you've actually got the two factors, which are that and that. Now, on the odd occasion, you will get, it won't actually work out and you'll have to kind of like do a double kind of like with the brackets. Would you guys like me to give you an example like that so that I can show you what the other version looks like? Let me know, or if you're happy, then we can just move on to the next question as well. Yep. So similar type of question here. Ah, bugger, I forgot to record that. Damn it. It's all right. I'll just download it later and then kind of do it all over again. That sucks. So here's another example on the side for you guys. Oh, actually not. Try this. Oh, yeah, Jacob, sorry. I'll just show you guys how you get those two values. So in your graphics calculator, just go into menu, go into equation, and then click on polynomial, which is F2, degree 2, because we're dealing with quadratics, and then just punch in those numbers, 12, negative 11, and negative 15. And it's going to come out with decimals, but you can have a look at the fraction here, which is 5/3. So if you look at negative 0.75, just go down to it. It's going to show you as a fraction, which is negative 3/4. All right, so what I would like you guys to do is try this, factorize and solve. So try this one here. This one you got to do a little bit of adjustments, and I'll talk you through the adjustments when you guys get to that point, all right? So here is no, that's not what I wanted to do. Hang on, let me just try that question again. Let's change that up because I know you guys saw that question. Let's go 6 minus 3. Okay, so try this one here, 24x squared minus 6x minus 3, that's equal to 0. Yeah, hopefully I'll leave the working up there for you guys. So try and have a, now this is, you got to do an adjustment later on, and I'll talk to you guys. But first, have a go at it, and then see what happens. And I'll guarantee you guys will see the pattern of what's happening there. Polydegree, use the graphics calculator. No. Poly 3 is actually used for cubics. So that's when you have a question like solve x cubed plus 3x squared plus 3x plus 1 equals to 0. So that's what poly 3 is for. And then you get 4, 5, 6, and so on. Philip, I don't do probability papers because have you seen my schedule, dude? Like, I'm already struggling to keep up with these 6 standards. I'd never hear the end of it if I start doing probability because that's like another 2 more papers added to the list. And plus, somebody else can pick that up. I think there's a few teachers that are doing a much, much better job than I could ever do. It's all right, Tom. Just chuck it in the graphics calculator and get those two values. and you've just got to kind of like rearrange them. Yeah, Eggman, that's a nice way to do it as well. That's fine. Yeah, see, I knew, Corin, can you just make sure you leave that answer up there, please? Because like when you check it right, Corin, with your answer, you see how 4x times 2x is actually equal to 8x squared? Oh yeah, nutshell math. Yeah, he does it. Yeah, he does it, and there's Liz Sneddon, and then there's Catherine Albertson. They all do some probability stuff as well. Yeah, so you're gonna get like quite a few variations of these questions, but I'll go through it now so that you guys can kind of have a look at it. So who was it that asked the 5-3? Jacob Hall. I think you wanted me to. I'm just gonna go through the calculator steps again if you want to have a look. So go into main menu, go into equation, and then go into polynomial. Degree is 2, and this time we're gonna get 24, -6, -3. And so you guys can see that you got a half, and then you've got a -1/4. Now, one thing that's really, really useful to kind of have a look at is if you look at your original equation, see if there's a common factor that you could potentially take out. All right. And I think if you have a look at it, you've got the number 24, 6, and -3. And I'm going to show you guys all the variations so you can kind of like mess around with this quite a bit as well. So here's my two answers. My first answer of x equals to -1/4, and my second answer is 1/2. Now, if I was to do this backwards, I'm going to get 4x is equal to -1, and then 4x plus 1 is equal to 0. Here, I'm going to get 2x is equal to 1, and 2x minus 1 is equal to 0. Now, the issue is this. When I put these two brackets together, if I actually try to expand it, the problem that I'm going to have is this. Watch this. If I do 4x times 2x, I only get 6x squared. And if I do 1, did I get that wrong? 4x, that should be -1, sorry. And if I do 1 times -1, I'm actually getting -1 here as a constant. So what you can see is that straight away you can see it, the difference between, sorry, that's not 8. Jeez, what am I doing? That's got to be 8x squared. Sorry. So you can kind of see that the answer that I've written in the multicolored, is actually missing 3 there. All right. So what you can do is you can actually just take the 3 and you could actually leave it outside here as one way. The other way you could do it, because then you'd go 3 times 8 is equal to 24, and 3 times -1 is equal to -3. So you could leave a 3 outside the bracket, or you could actually bring it inside the bracket and get something like this if you want. You could get 12x plus 3 multiplied by 2x minus 1, or you could have got 4x plus 1 multiplied by 6x minus 3. Because all I'm doing is taking that 3 and multiplying to each of those little brackets. Tom, yep, you could do that method as well. That's absolutely fine. So there's just like lots of ways you can actually get this answer. But look, I think we've spent enough time on this question because I mean, realistically, I'm looking at the last few years worth of papers. Like they know people use graphics calculators now, so they're not going to kind of put this question up there and give you as a merit. But just as if they do come up with it, then you guys know what how to actually work on it. All right, so let's go to the next question, and I'm going to give you guys about 3 minutes for this because I do want to record this question. I forgot to record in the previous one, so that I don't have to go back and do it again. So I'm going to give you guys 3 minutes, so we'll go through the answer at 8:21. And Mario, could you mind try changing the settings to like 360p? If that's not working, see what's the highest you can actually go. I'm good, thank you, Zifty. Smokey, not sure, man. Not sure what your school is actually doing, so I wish I could answer. Nah, Krishan, I think the exam's in 2 weeks' time. And Mario, the other thing you could also do is if you want to have a look at the questions and me writing on it, just click on the OneNote link on the description. And if you click on the OneNote link, then what happens is you should get the like it updates maybe like with a 2 minute lag, but it's you can still see all my notes up there. So just click on the OneNote, and what happens is just go down to exam papers. So on the side, it'll pop up with exam papers. Go down to 2014, where I've kind of highlighted it. That's where you want to go, and that document should get updated live. And be careful with that minus, guys. Like that's a common mistake that people end up doing. They ignore that minus. So that's just a bit of a heads up for you if you are working on this. Is 3 minus 4x or not? I'm not sure I understand your question there, Tom. Yeah, not sure why that's happening in Mario because I'm just tested it on another browser of mine, and it seems to be clicking along nicely. Uh, Eggman, you want to expand that a bit more? Cool. I'm going to go through this question, guys. So with this question, this right as a single fraction question, and I don't know, like every year they've been putting it, but it is a nice little question. Um, so the way you want to do it is just double check that you're actually expanding it, expanding the brackets correctly. So I'll actually do this. So we've got 3x minus 2. We've got minus 4x over x plus 1. Now, if you look at the denominator, and again, I'm going to use my highlighters here because it just kind of helps me visualize it a bit more. I've got two kind of algebraic expressions. So I've got to multiply by the yellow one on this side and by the blue one on the left-hand side. So in other words, I'm multiplying by x minus 2. But because I'm multiplying in the denominator, I've also got to multiply in the numerator. And likewise, for the left-hand side, I've got x plus 1 over x plus 1 as well. So with that in mind, and I guess this is the part where you need to be super careful, right? So what you want to do is you want to put everything under the same bracket, under the same denominator. So the denominator is going to be just x plus 1 times x minus 2. And it's really important that this part, which I always see people make mistakes, every year somebody makes this mistakes, but like what you can do is, the easiest way to do this is copy everything in the numerator as is, like as is. So maybe not the 3, but like 3 you can put in the front, that's all right, that's not too bad. But here's where the key part is, that minus there. And then we want to make sure we write it as x minus 2 like this. And I think this minus and this minus here, remember that it makes a positive, and that's where I've seen people make the most amount of mistakes. So with that in mind, I'm going to expand the numerator. When I expand the numerator for the first part, I've got 3x plus 3. Then I've got negative 4x times x and negative 4x times minus 2, which is going to give me minus 4x squared plus 8x, and divided by x plus 1 and x minus 2. And I've got to simplify the numerator now, which is going to give me negative 4x squared plus 11x plus 3, and that's all divided by x plus 1 and x minus 2. So looking at the schedule for grades, except with denominator in factorized form. Okay, that's fine. So you're going to end up, this question here is actually a merit. Correct single fraction, correct single fraction. I don't know what they mean by that. I guess you're looking at somewhere here for an achieved correct single fraction. Correctly simplified is going to actually get you a merit for this particular question. Cool, moving on. Yeah, how'd you guys go with that? Like, any questions with that one? Yes, your denominator could be written as x squared minus x minus 2. That's fine. Eggman, you have to simplify it as well. Like, just writing it in that line before, like, say, for example, you only write up to here, then you're only going to get an achieved. So you have to expand and simplify. Not the denominator, Uday, just the numerator is what the big concern is. So denominator, they said that they'll actually accept the answer in factorized form. But numerator, you definitely have to simplify it as much as possible. It's fully simplified. Fully simplified is expanded form, Jonty. So brackets is not an expanded form. Fully simplified is like expanding the brackets and then simplifying it. Let me know if I can move on, guys. With algebra, just a bit of a heads up as well, like with level 2 algebra, if you have to simplify answers as far as you can, then it's better to go as far as possible that you can, all right? Don't leave answers halfway through, especially in algebra paper, because like they like things to be simplified as far as possible. All right, this question here is actually one of my favorite questions because it's actually quite, how do I say it? Yeah, you know what? I'm just going to shut up and I'm going to let you guys have a crack at this. I'll give you guys till about 8:30 for this, all right? Just to see how far you guys go, because this is a question that's that used to be excellent. Um, so yeah, just kind of have a go through this. Possibly Narud, um, just because like they've kind of been asking, they've asked these types of questions before. So the moment they kind of, what I've noticed with these kind of exams over the last kind of like 5 to 6 years is that when a question that was like excellence back in the day is now worth like a merit. Like a really good example is like if you have a look at the MCAT, um, the MCAT is like, geez, when you look at the 2013 paper, it's like straightforward. And then after that, it just gets messy and crazy. Cool. I'm actually glad that you guys are putting some answers up here, and lovely to see like a couple of different variations popping up as well. Um, and yeah, so I'll actually go through it. Maybe I'll give you guys another 30 seconds. So just another bit of tip is that when you do have like a quadratic question divided by another quadratic, there is a trick behind it. So they're purposely putting that there. So they're wanting you to think a little bit outside the box. So I'm going to leave it at that for you guys. Yeah. Anyway, we'll come back to it. Zifty, this was back in the day. It was actually worth an excellence. But as I was saying to Narud, it might be a merit now. Back in the day, it was an excellence question. And I'll tell you why it was an excellence question. And I can tell you right now, those guys that have actually been putting the answers up, you're all stuck at you're all at merit at the moment, according to the schedule. All right, let's go through this question, yeah? I'm going to record. I have to record. So this question here, what you've got is you've got one quadratic divided by another quadratic and it equals to 3. Now, there's a couple of ways of doing this question. The first method is, of course, you could cross multiply. And I'm not going to do that method in this version because it's just, it's like a hell of a lot of work. Well, not really, but it's just like, what I'm saying is like you could do something like this. X squared plus 2x minus 8 is equal to 3 times x squared minus x minus 2. So basically what you can do is you can kind of like cross multiply, expand, and then rearrange to get a quadratic, put it equal to 0, solve, and you're going to get the two answers. All right, now that's one way of doing this. But however, that way of doing it is going to, you might not end up getting, you know what, let's just do it quickly while we're actually at it. I'm just being lazy. So if I was to do it this way, expanding the brackets, I'm going to get 3x squared minus 3x minus 6. Rearrange it. So I've got 3x squared minus 3x minus 6. And I've got take away x squared, take away 2x plus 8. So I'm going to end up with 2x squared minus 5x. And I've got plus 2. Now, if I actually put this in the calculator, and I know it says that the paper actually says show algebraic working. So you could actually use quadratic formula to try and solve it. But because I'm trying to kind of like rush through this at the moment, I've got 2, -5, and 2. So as you can see, what it's actually giving is it's actually giving us two answers, right? So this, let's assume that you've actually done this through quadratic equation, all right? So let's say you're going minus b plus or minus b squared minus 4ac over 2a. You do all the working out and you end up with x is equal to 2 and 0.5. Now, the problem with this is that like when you do it this way, yes, you're right. The answer is actually 2 and 0.5. That's because your calculator is actually not seeing the equation before the pink line. All right. So what do I mean by that? Well, let me show you another way of doing this. The other way of doing this is to actually factorize the numerator and also factorize the denominator. When I do that, what's going to happen is I'm going to end up with, in my numerator, I've got x plus 4 times x minus 2. And in the denominator, I've got x plus 1, is it? Yeah, x plus 1 and x minus 2 is equal to 3. Now watch what happens here. I can actually get rid of the x minus 2 and x minus 2. And what now happens is I've got x plus 4 over x plus 1 is equal to 3. Cross multiply. I've got x plus 4 is equal to 3 times x plus 1. Expand the brackets. I've got 3x plus 3 and x plus 4. So 0 is equal to 3x plus 3, and I'm doing minus x minus 4. So what happens here? I'm going to end up with 2x minus 1. So 2x minus 1 equals to 0, which means 1 is equal to 2x, and then x is equal to a half. Now, in this particular version, what's happening is I'm actually getting x is equal to half. All right. And the truth is, this is the correct answer. X is actually equal to a half. And the reason why we actually have to say that x equals to half, and even though in the other version, it actually says that x equals to 2, you can't actually get x equals to 2 as an answer, because what happens is if we take this equation, x plus 4, x minus 2, over x plus 1 times x minus 2. Now, if I put x equals to 2, I'm going to get 6 multiplied by 0 divided by 3 times 0. So what it's going to give me is 0 divided by 0. And remember that you can't actually have 0 divided by 0 cannot actually equal to 3. Because remember, all of that is equal to 3, right? So you can't actually say 0 divided by 0 is equal to 3. So what you have to say is that therefore x can't actually be 2. And I think you have to mention that, and that's how you end up actually getting an excellence grade for this. If you leave your answer where it's just 0.5, then you're going to end up with a merit. Factorized and simplified, or even if you just put like 0.5 at the end, you're just going to get an achieved. But if you show the working solved for x, you actually end up getting a merit for it. So it's a bit of a weird question because it's like, and I know they used to ask that for a couple of years and then they stopped after that because I think they kind of got it, like kids got the pattern of this question. So they'll just kind of factorize it, and then it became like one of those cookie cutter questions. So they stopped kind of asking it after like a few years. But anyway, that's pretty much the reason why you end up getting an excellence, is because that x can't actually equal to 2, even though in the original, kind of like this part here, we actually got the answer as 2 and 0.5. Cool, that's it for this question. All right, let's have a look at the chat here. Yes, Elite, I think, yeah, I think Elite, you've got to kind of mention that, you can't divide by 0, and also that that 0 divided by 0 can't actually equal to 3. Yeah, it's funny, right, Isabel? Like a lot of level 2 questions started transitioning into level 1. Yeah, you're on point there, Narut. Um, Seclor, what if you substitute and 0.5 and state that x equals to point? You could do that, but you still need to explain why. I'm trying to think. I know what you're trying to say there. Yeah, actually, no, you can do that. I remember somebody doing that before for that question, and there was a paper back in 2014, which was not the official paper, but you could actually resubstitute just to check which of those two answers actually work, and then you can kind of say that yeah, x equals to 2 doesn't actually work because you can't actually have it equal to because what happens is that, remember how it says like this part here, if you go back and substitute, right? Because you know how I got x squared plus 2x minus 8 divided by x squared minus x minus 2. If you put in 2, you're going to get 4 plus 2 times 4 minus 8. Sorry, 2 times 2 minus 8 divided by 2 squared is 4 minus 2 minus 2. And once again, you're going to get 0 over 0. So yeah, you could actually kind of resubstitute after you get those two answers, substitute it back in the equation and kind of say that, well, actually x equal to 0.5 works and x equals to 2 doesn't actually work. Yeah, Jacob, yeah, that's exactly what Ciclo was saying. Um, well, I think when I looked at the answer schedule, you do want to have some sort of statement to say that x can't actually equal to equal to actually 2, because that's just really important that you actually have to kind of say that, yeah, it's not possible for that. What do we do after we simplify and get the equation? I'm not sure which part you're up to, which part you're talking about, Tom. While I will kind of answer those questions, but if you guys want to get started on that next question, which is C1, the first part, line 4. Oh, Tom, you're talking about the 2x squared minus 5x plus 2. You're talking about what do I do after that part? Huh, that's an interesting way of looking at it. Where is this? Kinkles. That's such an interesting way of looking at that question. Like, I never even thought about that. But see, it actually works out when you actually put it in x squared, though. So if I put x squared minus x minus 2, then -1 squared minus -1, you're right. But then that x equals -1 is not a solution, though, so we don't have to worry about it. So we're trying to figure out for when is this going to equal to 3, right? So Tom, to go back to your question, Tom, notice how it's 2x squared minus 5x plus 2, right? So you put down a is equal to 2, b equals minus 5, c equals to 2, and then you use the quadratic formula to try and solve it. So Kinkels, you can't actually say that because that won't give you any kind of solution at all. Um, so it won't actually, it's irrelevant in this case because we're looking for solutions that actually equal to 3. So we know that -1 is not going to work anyway, so we don't have to actually worry about it. Let me see. I'll try and see if I can get a graph of that so I can show you guys what the graph actually looks like. X squared plus 2x minus 8. Sorry guys, I'm just going to switch the screen to Kinkils. I'll show you this so it might kind of make sense. So if you notice, so we already know that when we put x equals to -1, there's actually no solutions there already because this curve, this red line is never going to touch that blue line because the blue line is -1. So we already know that there's actually no solution there already. So we don't need to worry about it. But what we're trying to figure out is when is it actually equal to positive 3, right? So when is this equation equal to 3? And if you look at it, it's only at one point when it actually equals to 3. That's when x equals to 0.5. Hopefully that kind of clarified your question there, Kinkels. Cool, guys. We're looking at question C1. And Tom, I know you were asking me about quadratic equation. So we're kind of going to re-look at that. Just to give me a second. My thing has crashed again. By the way, guys, I got some good news. I did get a new tablet. I just haven't finished setting it up yet. Hopefully it's it's good to go in the next couple of days so I can actually start using it properly. Because this one, as I said, it is on its last legs and it's died, or it's dying a slow death in front here. I'll tell you what I'll do is, and I can't put that up there. I've got to, sorry guys, I've got to log out and log back in. Give me a second. Because that rearranging question is actually a nice question to do. I'm aware of the time, so I'll try and speed it up a little bit. Why does NDI scan converter crash? Well, that's an interesting way of doing it. All right, Corin. There we go, we're back. All right, guys. So this question here, um, hope you guys had a chance. Yes, Anna, that's exactly what I was looking for. You do have to use that. That's exactly what you got to do. So this is one of those super annoying questions because you don't actually see it until you have a play around with rearranging it. Let me know if you guys want me to go through the answer. I can wait for a couple of minutes before I go through it if you want. Yep. You got it, Elite. That's the one. So yeah, you guys have to use the quadratic formula for this. I'm just going to give you guys a bit of a heads up on it. Um, and if you ask me how do I know when to use quadratic formula for something like rearranging, or do I use logs or do I use powers and whatever the case, there's two questions I'm going to do. I'm going to do this one and then there's another question I want to do later on after this, before jumping on, if we have time to answer those remaining questions. But yeah, I'll give you guys some time first to kind of have a go at it. Use the quadratic formula and see if you can get it. I'm going to give you guys maybe like another 90 seconds and I'll go through the answer with you. Sure, Jonty. Sorry, mate. Quadratic formula is what would the A value be? Don't know. I have an extra. Oh, R. All right. So let's do this question here. I'll actually go through it. All right, guys. So for this question, as I was mentioning before, like we do need the quadratic formula to kind of work on this. And the reason we need the quadratic formula is if you look at the equation, we've got h is equal to r x squared minus tx, right? We're going to rearrange, bring the h to this side, rx squared minus tx minus h. Um, and as I said to you guys, like, how do I know that this is going to be, how do I know I'm going to use a quadratic formula? Well, it's quite simple because I've got x squared there and I've got x there by itself. And straight away, that should kind of give you a hint that you're actually going to be working with a quadratic. And this is very similar to other types of questions as well. Like anytime you see like kind of like three elements, and then you've got one of them that's ending up being like a squared, and the other one is half of that, then you're going to be working with quadratics. And sometimes it's like you've got to manipulate it, but I know we've talked about questions like that later on. But anyway, let's going back to this. So what I've got here is 0 is equal to ax squared plus bx plus c. So it's just a matter of matching up what my a values are, what my b values are, and finally, what are my c values. So I've got literally, I mean, there is like no rearranging in this. It's literally just putting this in here. So we got minus b, which means we've got negative of negative t, plus or minus square root of negative t squared, minus 4 times a, which is r, times c, which is negative h, over 2 times a, which happens to be r. Now, really important that just I simplify a little bit. So I'm going to get t plus or minus square root. Negative t squared is just t squared. And then I've got negative 4 times negative h is plus 4rh. And all of that is over 2r. Now, this question back in 2014, which paper is this? 2014, is worth a merit right there. There's no achieved for this part. It has to have yeah, it's just a direct merit question there. Cool. That's it for this, and we'll move on. Yeah, I think you guys got it, and hopefully, who was it that asked? Jonty, I hope you got the question of how to answer it. Somebody asked about King skill. Yep, yep. Yeah, I think Corin just got to be careful with that negative t squared, because the negative t is inside the bracket. When we square it, it's going to end up being a positive squared. So, and then when you have negative, yeah, my only concern is that negative t squared that you got inside the bracket. Cool, guys. Are we ready to move on to one more question, which is a trick question, and I thought it's a good trick question to do at this point anyway, because you might, or we just do the quick log questions and we get it out of the way because they're like really quick questions. And then I might just do the excellence question later on and post it all together. Yeah, let's do the log questions real quickly, yeah? There's a couple of 2 achieved questions and 1 excellence question that we're going to do. Cool. I'm going to put these up here. I'm going to give you guys maybe like, I don't know, 2 minutes to do this. Just both of these questions. They're both achieved questions. And I will actually write the log rules for you guys as well, because you do get the log rules in your formula sheet. So I'll write the formula, the two parts that you're going to need for this question. Isn't it the same negative t? If the negative t is inside the bracket, Corin, then it is okay. But if you didn't put it inside the bracket, then you're not on the right track, mate. All right, so what are we looking at? Oh, here we go. This is one of the rules that's actually given to you guys in your formula sheet. You guys do get a formula sheet, and this is what the formula sheet will actually say. If y equals to bx, then x equals to log by. Cool. That's all you guys are going to need. I'm going to give you guys about 2 minutes to kind of work these 2 questions, and then we'll do that excellence log question after that. It'd be awesome if they keep asking you guys questions like this, because those are some of the 3 easiest points you will get for achieved. All right, guys. So I'm going to go through the first one. I'll actually record both of them together, and then you guys can kind of, I'll pause and ask the questions after that. So with question 3A1, just remember that in your formula sheet, you're going to have the stuff that I've written in black up here. It is actually available in your formula sheet. If you do forget it, you can just kind of pull it out and just rewrite this. So in our first part, what we actually have got here is, notice how it says x equals to log 381. You can do this in one shot in your calculator. All right, you don't even need to do any kind of working. All you do is you go into the calculator, go into main menu, all right, and all we're going to do is see this log button. We click on log 81 divided by log 3. That's all we're going to do. And there's our answer 4. Done. Quickest achieved that you could possibly get. By the way, if you wanted to write that long method, then you would write something like this. 3 to the power of, let me just put that here. You're going to get 3 to the power of x is equal to 81. And then you take logs of both sides. So you go log 3x equals log of 81. Bring x to the front. So you can kind of see it's just wasting a lot of time doing this. While it's good practice to do this if you're doing some of those excellence questions, but really for an achieved question, when you know it's an achieved question, you don't really need to go with the working. Just chuck it up straight away in the calculator and then kind of be done and dusted with it for an achieved. So looking at the second one, what we have is we've actually got x to the power of 3 equals to 343. Now, if you've been keeping up with my tutorials, you know that you can just get rid of that 3 by multiplying 1/3, which means you've also got to do 1/3 on the other side. So multiply that by 1/3 and raise 343 to the power of 1/3. So when we go 343 to the power of 1/3, make sure the 1/3 is in a bracket. There we go. Chuck that on, and you're going to get 7 right there. So we're just going to put x is equal to 7, gets you another achieved for this question. So yeah, 2 really kind of like straightforward log achieved questions. Yeah, keep an eye on it, right? Like they have kind of converted some of these questions into like merit questions. So have a look at the last couple of years' papers worth of log questions, and you guys will understand what I'm talking about. Cool. Let's go to the next question. How are you guys going here? Any questions with that? Yeah, Corin, you could just do that as well. Like, there's so many ways you can do it. Like, it's just up to you what you find easy to kind of work through. All right, guys, we're gonna do the last question. It is an excellence question, which is this one right here. This is actually one of my favorite questions, just because it actually really does test your algebraic skills. But yeah, I'm going to leave it up there for maybe about 2 minutes and kind of like go through it. Sorry, the 1/3, because I want to have x's to the power of 1, right? Like, so think about it like this. You know how you do, if I have x to the power of 5 equals 7, then I would write x is equal to 7 to the power of 1 over 5. Or if I have something like this, x to the power of 3 over 2 equals 10, then x is equal to 10 to the power of 2/3. Because by multiplying by the reciprocal of the number, you actually make it equal to 1. And that's what I'm doing here. So if you think about it, 10 actually has got a power of 1. And if I go times 2/3 times 2/3, 3 over 2 times 2/3 become 1. And the other side, 1 times 2/3 become 2/3. So it's just multiplying by the reciprocal of whatever you have. Hope that made sense, Tom. Yeah, yeah, we did that right at the start of this series. Hey, John T, like just little tricks on how to get rid of powers real quickly. Anyway, let's go to this question here. As I said to you guys, I was going to leave you guys a couple of minutes for it. Now, guys, I'm going to give you guys a couple of hints here because I know that it can be daunting without those hints. Just remember that when this is the hint I'm going to give you. Hopefully, this kind of helps you. See, I knew you guys were going to go down that way. Cotton Slayer, check out the hint I've given you. That's all the hint I'm going to give you. See if that helps. Unfortunately, in this case, you won't be able to take log of everything yet. I'm trying to think. It might work. Actually, it might work. Log 5 over maybe faded. Have a go, man, because I don't know. I don't know what you're like. I think I know what you're thinking, but have a go and let's see if you get the answer. The answer is 12.14, by the way. That's the answer I'm looking for, but like, yeah, if that helps you. Nah, there's no plus or minus. It's 12.14 is the answer I'm looking for. There you go, Japnor. Now, this question I can tell you guys, like this question is an excellence question, and yeah, there's a very good chance like question like this can still come up. And you guys will notice once you do the first step, it's the first step that's the hardest, right? I think once you figure that out, then everything becomes so much more easy after that. That's why I wanted to do this question because it's just kind of 1.3. No, I'm looking for 12.14 current wear. The clue is it's in the hint that I've given you guys. That will be the biggest help for you guys. Yeah, few people getting the answer. Guys, I think if you get the answer, that's all we're working on today. Yeah, so but you're more than welcome to hang around and just see how we go about doing this. I will record this right now. Um, I'll actually start from the beginning, right? So that can kind of explain it as well as record at the same time. No, we can't do that, King skill. King skill. King kills. Yeah, we can't do that, mate. I'll show you what we're gonna do. All right, guys. So with this question, I always start off with this, right? Like it's always good to go back to level one and kind of revisit some of the rules. And one of the rules that I kind of keep going back to is this: when you have ab to the power of x, remember that this is actually a to the power of x and b to the power of x, and that's exactly what we're going to be doing here. Because if you think about it, the I can't actually make 5 and 2. I can't write 5 as 2 to the power of something. I can't actually write it as a base of 2 because it's not like one of those really nice numbers to work with. But the x though is common in both of them. So what I can do is I can actually take x out. How do I take it out? I write it like this: 5 times 2 to the power of negative 2 to the power of x is equal to 15. So that's what I meant by before in this particular thing going from here to here. Now what we're doing is in this question, we're actually going backwards. All right. By going backwards, what we're doing is we're actually taking x, which is the common power, out, like almost similar to like kind of like factorizing, but with powers. It's kind of hard to say, but yeah, you get what I'm trying to say. And then after that, what do we have? 5 times 2 to the power of -2. That one we can just do straight in the calculator. So we're just going to go 5 times 2 to the power of -2. And that's 1.25. Guess what? We've got one of the easiest excellence questions out here because we've got 1.25x is equal to 15. Then we take logs of both sides. So we got log 1.25x equals log of 15. Pretty much what we did in an achieved question, right? Because bring the x to the front. We've got x log 1.25 is equal to log 15. And then x is equal to log 15 divided by log of 1.25, which is going to give us a 12 point, whatever it is. What is it? So log of 15 divided by log of 1.25. So that's giving us 12.14. So grades wise for this question, all right, now this is like, I would say, one of the most easiest excellence question because x found is going to get you an excellence grade. So that's actually worth 7 points. Written in log form gets you a merit. So getting up to here, written in log form, yeah, this is getting up to this line here is going to get you a merit. Expression simplified is going to get you an achieved, which is either, I reckon even here, you're probably going to get an achieved right there. Yeah, but safe side, we're going to go with achieved here. But yeah, that's pretty much it for this question, guys. Yes, there is King Kills. I will paste it for you. There's a schedule for these tutorials. I'm not like, yeah, these are all exam questions I'm working out. This is 2014 exam that I'm working out of. So that's the 2014 results. Oh, that's a great question, man. I love that question because it's a look what happens if we do that. Log 15 and you went fraction button of log 1.25. Yeah, cool. Okay, this is a beautiful question. The reason why this is not working out for you, I think was it C color? Yeah. What happens is this, when you actually put the fraction button, right? What you've just asked the calculator to do is this, 15 over log 1.25. That's what the fraction button does. So when you use the fraction button, that's what it does. But when you use the divide button, it's actually doing this right here. Now, if you were to put a bracket around the log 15, watch what happens if I put the log 15 in a bracket and then use the fraction button. I should be okay with this. So I hope you can actually see that difference there of the two bits there, C color. No. Now we can't Eggman. We can't actually combine it like how you do the 10 to the power of -2x plus 1 because they're not the same base. 5 and 2 are not the same base. So it's only when they're the same base that we can actually put it together. You can also add the whole equation on graphics calculator. Yep. You could do that as well. That's a really good point. Like to check your answer, you could actually go into equation mode, go into solver, and type the whole equation in as well. So you could actually go 5 to the power of x multiplied by 2 to the power of -2x. And that's all equal to, what is it, 15? And if I click on solve, that's going to give me the answer of 12.14 as well. Yes, listen to Zirak there. Zirak's on point when we're talking about putting everything in brackets, man. Just Jacob, are you talking about taking the x out? Is that the first step you're talking about? Oh, King Kills. Yeah, man. Like, give me a second. Like, if you go to my website, like, there's a link on my in this description. If you click on it, it'll take you to a website where I have all the schedule up there and all the previous ones that I've done. It's all up there as well, so you can go and watch any one of them. Like, it's some of them are like very like even the OneNote that I'm using right now, it's available. So if you go to my, I'll share with you guys on the screen. Where is it? Yeah, so if you go to, hang on, let's just go here. Yeah, so if you just jump on the website, all the schedules are there, and then all the whiteboard. So every year, whichever board that I work on, you can access it. So if you access today's one, it'll just take you to the whiteboard that's online. So as I'm working on it, it takes a bit of time to load up, but once it loads up, it's all good to go, man. Because it is getting a bit big at the moment. So what are we working on? 2014 algebra. So just click on that, and you should actually see all my notes there, all of my working and everything. Yeah, like I said, it'll take a bit of time loading up, but it's there. No, I don't do probability at all. Yeah, by the way, that's us guys for today. If you're just hanging around to have a chat, that's fine. Um, but otherwise, I will catch you guys next. I think the next tutorial is when are we doing it? When are we going next? We're going 15th. So I guess I'm seeing you guys Wednesday to continue the Calculus 2013 paper. Oh, yep. Leo, you're absolutely right. You could do that as well. Yep, that's not a problem. I think that should work as well because you're going to get log 5 minus log 4, which is the same as log of 1.25. Yep, that should absolutely work, Leo. That's good thinking, man. Yep, no worries, guys. Have a good one. Um, yeah, hopefully I'm all good to go on Wednesday. It'll be my first day back at school, so should be good fun. Oh, nice, Achim. Well done. Calc paper, Bhavik, I think we're on at 8 p.m., man. So yeah, it's usually 8 p.m. except on Thursdays when I work late. Can you try to separate 2 minus 2x into 2 minus 2 times 2x? What are you trying to do there? Sorry, Annabelle, I'm just looking at your working at the moment. Can you separate 2 minus 2x into 2 minus 2 and 2x and 5 to the power of x? Then make... yeah, that should work. Did it work? Did you try it out? I see what you're trying to do, Annabelle. I think it might actually work. Yep, no worries, Aditya. All good. I'll see you guys on Wednesday. I'm intrigued by Annabelle's question. Let me have a look at it, Annabelle. Hang on. What do we got? You said, so it was 5x times 2 to the power of negative 2x equals 15. Now you did 5x times 2 to the power of negative 2 times 2x is equal to 15. Then you said 5 times 2 to the power of x is equal to 15 divided by 2 to the power of negative 2. Let's chuck it on and see what happens. So we're going to get 10x equals 15. There's lots of ways of doing this. It's quite nice that you guys are coming up with a few different ways. That's going to give me 60. So then x is equal to log 60 divided by log 10. Is that going to work out? Why is it not going to work out? Let's find out. Log 60 divided by log 10. Where are we making the mistake? 5. Oh, actually, no. I think I know where your mistake is, Annabelle. Sorry. That's not going to work out. I just got carried away there. This right here is actually not equal to this. Because remember, you can't, when you multiply, you're actually going to get negative 2 plus x. That's actually not right. So you can't actually split it into negative 2 and negative and x like that. So that wouldn't actually work out for you. Sorry, I know I kind of dragged on with that, but no, it wouldn't work because it's actually getting multiplied. When the powers are getting multiplied, you can't separate them because Remember that when you have AM times AN is actually equal to AM plus N, and what you're trying to do is AMN equals AM plus N, and that can't actually work out. Yeah, so that won't actually work for you. Leo's method, what he did would work because he's taken logs on both sides and then managed to kind of manipulate it. No worries, Jacob. You have a good one, man. Any other questions, guys, before I take off? As in 2 to the power of negative 2x. Yeah, no, I get what you're trying to say, Annabelle, but like you can't separate that 2 to the power of negative 2x as 2 to the power of negative 2 times 2 to the power of x, if that makes sense. So you can't actually split, when you have 2 to the power of negative 2x, you can't actually split this as this. This is incorrect. That's what I meant by. Because if you split it, then like when you put it back together, you're actually adding the powers, you're not multiplying the powers. So that's why you can't split it like that. Hopefully that made sense. All right. Cool, guys. I'll leave you guys with that. Yeah, looking forward to seeing how my school is for the first time in a long time. But I'll catch you guys on Wednesday, all right? Have a good night, guys.